everyone, this is Julian and this is probabilities using combinations and permutations presented by the group 11. So here are our members: Sumalino Julian, Tomongha Zaira, Taroba Christine, and Tan Kim. These are our learning objectives: compute probabilities using combinations and compute probabilities using permutations.
P parentheses event equals number of times the event occurs over number of trials. What is combination? A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combination, you can select the items in any order. Combination formula: n choose r equals n factorial over parentheses n minus r factorial r factorial. Using combinations, Jake has the option of selecting 3 books to read for humanities course. The suggested book list consists 10 biographies and 5 current event books. He decided to select 3 books at random. Finding the probability that all 3 books are selected will be current event books. So, our solution is 5 choose 3 is equal to 5 factorial over 5 minus 3 factorial 3 factorial equals 5 factorial over 2 factorial 3 factorial, and then write the factors of 5 times 4 times 3 factorial, and then 2 factorial 3 factorial. You cash out 3 factorial and then you reduce 4 by 2 factorial, so 2. 5 times 2 is equal 10, so there are 10 ways to choose 3 current event books. The total number of outcomes in a sample space is 15. Choose 3 because there are a total of 15 books, 10 old books and 5 current event books. So 15 choose 3 is equals to 15 factorial over 15 minus 3 factorial 3 factorial equals 15 factorial over 12 factorial 3 factorial. You write the factors again of 15 factorial, and then denominator is 12 factorial, and the factors of 3 times 2 times 1. You cash out the 12 factorial and then reduce the 15 by 3, so it is 5. Reduce 14 by 2, so it's 7. So 5 times 7 times 13, the answer is 455. So the probability of selecting 3 current books is 10 over 455. Reduced to the lowest term, that is 2 over 91, which is approximately 0.022.
Solution: 52 minus 4 is equal to 48. Why did I subtract? Because there are 4 aces in the deck. There's only one way to get all 4 of them in your hand. In that point, there are only 48 cards left with the other card in the hands. So that's why there are 48 ways to have 4 aces in 5 cards hand. The total numbers of hands with any 5 cards is the combination of 5 cards chosen 52 or 52 chose 5. 52 choose 5 is equal to 52 factorial over 52 minus 5 factorial 5 factorial is equal to 52 factorial over 47 factorial 5 factorial, and then you write the factors 52 until 47, and then on the denominator you write 47 factorial and then the factors of 5, and then you cross out 47 factorial and reduce Reduce 52 by 4, which is equal to 13. Reduce 51 by 3, which is equal to 17. Reduce 50 by 5, which is equal to 10. And then lastly, reduce 48 by 2, which is equal to 24. And then you multiply 13, 17, 10, 49, and 2. Then that results to 2,598,960. The probability of getting 4 aces and 48 over 2,598,960. And then reduce the lowest term, which is 1 over 54,145, which is approximately equal to 0.00018 chance.
Permutations. What is permutations? A permutation is a mathematical calculation of the number of ways a particular set can be arranged where the orders of the arrangements matters. Using permutations, a combination lab has 40 members on it from 0 to 39. Find the probability that if the combination to unlock it consists of 3 numbers containing 1, 2, and 3 in the same order, assume that numbers cannot be repeated. Solutions. 3 permute 3 is equal to 3 factorial over 3 minus a 3 factorial is equal to 3 factorial over 0 factorial, then 3 times 2 times 1 over 1 is equal to 6. There are 6 ways to create a combination with 1, 2, and 3. The total number of combinations is a permutation of the 40 numbers taking 3 at a time, or 40 permute 3. 40 permute 3 is equal to 40 factorial over 40 minus 3 factorial, just 37. So 40 factorial over 37 factorial is equal to 40 times 39 times 38 times 37 factorial over 37 factorial. Then you cross out 37 factorial and then you will have the answer 59,280. The probability of the combination containing 1, 2, and 3 is 6 over 59,280, and then you reduce, which is equal to 1 over 9,880. Approximately, it is 0.000101. 6 is our numerator because that's the number of times the event occurs, and then the denominator is 59,280 because that's the total number of the trials, or the probability.
So the next problem is, what is the probability of a 4-digit pin that does not have repeated digits? So our solution is n to the power of r. With substitute, it's 10 to the power of 4, which is equal to 10,000. So why 10? Because there are 10 possible values for each digit of the pin, so 0 up until 9. So since it is a 4-digit pin, so we have all 10 possible choices in all the digits, so it is equal to 10,000. To have no repeated digits, we are selecting without replacement. So as we learned from previous lessons, you just do this. So in the first number, we have 10 possible choices. Since it is not repeated, so we only have 9 possible choices left for the second digit. And then since that number is not repeated again, we have 8 left, 8 possible digits left. And then for the last digit, we have 7 possible choices left. So 10 times 9 times 8 times 7 is equal to 5,040. So using the permutations, it is 10 permute 4, which is equal to 10 factorial over 10 minus 4 factorial, which is 6 factorial. So 10 factorial over 6 factorial is equal to, then you write the factors of 10, 10 times 9 times 8 times 7 times 6 factorial, then over 6 factorial, then cross out 6 factorial, then you will have the answer 5,040. But that's not the end. So 5,040, that's our numerator. That's the number of events. That's the number the event occurs over 10,000, the total number of trials.
And then you reduce, which is 63 over 125, which is approximately 0.504. That's how you use permutations in probabilities. So, a little summary for our report. The difference between combinations and permutations is their order. So, in combinations, as discussed by Tomongha, the order does not matter. And then, as discussed by Toroba, in permutations, in solving probabilities using permutations, the order does matter. And then on our next slide, we have our formulas for the combinations, which is n choose r, which is equal to n factorial over r factorial times n minus r factorial. For the permutations, it is typically the same except that there's no r factorial. So it's just n factorial over n minus r factorial. There's no r, there's no other r factorial. It is because in permutations, repeated numbers are not allowed. So that's why it's just n factorial over n minus r factorial. And thank you and God bless. So do you have any questions regarding our topic? So if none, I think that is all. Thank you very much for listening.
何